Hey, hi guys. So welcome to day 12 for solving CSES graph. Today we'll be solving flight routes. Okay. So I'll give you guys 1 minute to just read out the problem and then we'll start on. Okay, let me read it out for you. So basically your task is to find the case shortest flight routes from Sedula to Metsala. The route can visit the same city several times. Note that there can be several routes with the same price and each of them should be considered. The first input line will have three integers, n, m, and k, the number of cities, the number of flights, and the parameter k. The cities are numbered from 1 to n. The city 1 is Sirjala and city n is Metsala. So to simplify the problem here, let's say we have a graph, okay, and it is saying that let's say you have one node, then another node, and we have to find the shortest path from 1 to n. Okay, so we did it Djikstra many times. That if we have a node and if we have another node, we know how to find shortest path. Okay, like let's say this is our node, this is n node. Okay, so this comes under SSSP, single source shortest path, and we know already that we have Dijkstra for it, so there's no problem. But here there is a catch in the problem that we have to find the k shortest path. Okay, k shortest path means let's say if we have from and yeah. So if we want to go from here to here, we can go from 3, you can go from 7, let's say 6, you can go from 5, you can go from 4, and you can go from 1. You want to go, okay. So let's talk about the root of 1 to 1. So basically it will be 5 plus 4 plus 1, so 10. And then we can go from 3 plus 2, that is 5. 1 plus 6 plus 2, 9. So there are, let's say, we have many roots. Okay, so you have to find not only sort, you have to find the k shortest. Okay, so it's just a variation of Dijkstra that we need to understand it here. In Dijkstra, what we do. So first of all, we talk about in Dijkstra what we used to do. We have a distance vector where for all the distance for all the nodes we initialize it as infinity or as some big number. Okay, and then in relaxation we see if we can get there in less number of cost. Okay, here we can't just say that distance of v equals to infinity. Okay, here we need to know that okay, are we talking about shortest, second shortest, third shortest, fourth? So we'll create something like distance of node, and here we will say k. Okay, it means kth shortest. Okay, so if it is distance of v0, it means that it is the shortest path for v. Okay, if it is distance of v1, it means it is second shortest path for. If it is v2, it is for third shortest path for v. So like now another problem is we always used to relax that when we go from one node to another. That okay, if we remember the relaxation stuff, right? That let's say for auto v in the adjacency of u, the if I'll show you guys, wait 1 second. Search the economic algorithm, CPL algorithms. So yeah, so you can see that this is a relaxation stuff. Okay, d of 2 equals to mean of d of 2 comma d of v plus 1. Okay, so we did this relaxation. Okay, so now we can't do like that. Okay, we need to check that okay, if there is room for improvement for any of these from 0 to k minus 1, we'll improve. Okay, because we want at every point we want the k shortest. Okay, so without wasting any time, let's go for implementation. They will try to our correct our concept. Yeah. So let's first take the input and then I mean, we will have there for the I guess adjacency list. So let's say vector of pair of from uh, yeah, it is for storage cost and to where node. Okay. Then we have dist vector or vector. It is not only vector because as I already told that we will have to know that it is distance according to smallest, second smallest. We are storing for everything. Okay. And yeah, I guess uh, we are good to go. You see the constraints here. Okay. No worries. So yeah. Now let's in solution we take the input obviously. So let's take the input. So first uh, C and K. Sorry. N. Okay. Now we will resize our adjacent series. This one. We resize this also and this one. And for we take the input by y equals to and y equals to n equals to we'll first resize. Okay. Just of I dot resize K because it is a vector of vector for each distance we have K another distance. Okay. Yeah. Yeah. And we initialize for L j equals to 0, j less than k j plus to सबको infinity से हम कर देंगे. Okay. Just of I is equals to 118. Okay. That's a fairly big number. So it's fine. Sorry. Yeah. Okay. Now we will just of 1 0 means equals to 0 because to go to the 1 node, obviously we are at 1 node, so it will be 0. Yeah. So now take the input and y equals to 0 and then m plus and then a b c c a b c and then adjacency of u dot push back. Uh, sorry. Yeah. U dot push back b comma c because sorry it will not take a. Yeah. So dot push back b comma c and then we just call the view as actually whatever let's say actually. Okay. And we just print that तुम्हारे पास आ ही जाएगा के साथ so I'm just print it out. Okay. And thank you have any no conditions निकालना है. Yeah. And just write the Djikstra implementation. So word DA Djikstra. And I guess nothing more changes. Everything keep intact. First of all, you have to make the priority queue. Okay? So that is one of the most important part in when we are implementing the Djikstra. So we have a pair of LL, okay, that we know that, and since we are using a min here, so this uh, vector pair LL, and I think it is greater pair than. We need to know the syntax for it. It is fairly important. So yeah, I think this should be it. Otherwise, you can use that negative hack that I've already taught in other videos. That uh, it it works as a max if. So using the negative hack, you can make it work as a menu. So yeah, let push. Push. 0 comma 1 because 0 cost लगेगा हमें to go to the one node and stand for p0 empty. What we will do here is u equals to pq dot top dot second and then d that is distance yeah pq dot top dot first. Okay, pq dot pop and here comes relaxation. Before relaxation एक चीज हमें करना होगा कि अगर भाई लिस्ट ऑफ जो u है उसका k-1 मतलब कि केथ जो सबसे बड़ा वाला केथ मैक्स है वो अगर लेस देन डी है ठीक है बेसिकली कि हमारा जो लिस्ट ऑफ यू k-1 मीन्स टू गो टू द यू द के स्मॉलेस्ट जो है हमारा विच इज ऑलरेडी लेस देन डी ठीक है हमारा तो फिर यही नहीं सुधार सकता तो जीरो और फर्स्ट क्या ही सुधरेंगे सबसे बड़ा तो यही था तो कंटिन्यू तो मतलब ही नहीं ठीक है तो ये एक कर सकते हो उसके बाद तुम रिलैक्सेशन वाले स्टेप्स फॉर ऑटो हेज इन एडजेसेंसी ऑफ यू यहाँ पे तुमको करना होगा अगर v इक्वल्स टू आई थिंक h डॉट फर्स्ट एंड फर्स्ट इक्वल्स टू h डॉट सेकंड तो इसको बेसिकली रिलैक्सेशन ऐसे कर सकते हैं कि डिस्टर्ब सिर्फ देखो यार इसमें डिस्टर्ब नहीं रखेंगे हमारे पास क्या डिस्टर्ब भी है क्या ठीक है ये हम कि अगर सबसे बड़ा वाला जो है अगर वो ग्रेटर है किससे कॉस्ट प्लस जो हमारा जैसे हम आए थे किससे आए थे डी से आए थे ठीक है अगर ये इससे बड़ा है ठीक है यानी कि इधर जो ऑल्टरनेटिव हम जा सकते हैं तो हम पी की डॉट पुश कर देंगे डिस्टर्ब भी और उसके साथ हम ये पुश कर देंगे डिस्टर्ब वी ऑफ k-1 और हमारा जो भी हाँ ये हो जाएगा पुश और आई थिंक क्या फिर से बट हाँ इसमें एक प्रॉब्लम यह है कि देखो लेट्स हमारे पास पहले 3 के है ठीक है 100 120 100 150 ऐसे 150 देन 180 ऐसे करके तो चार ओके एंड तुम्हें ऐसे सॉर्ट इसको सॉर्ट करने पे मिल गया 140 ओके सॉरी सो अब इसको जैसे इसको हटाने पे 140 मिल गया तो अब k-1 इस पे जो होना चाहिए ना तो वी नीड टू ऑलवेज सच दैट की ये फिर वापस से ये वाले मोड में ठीक है तो उसके लिए हमें सॉर्ट करना होगा तो हमेशा हम क्या करेंगे सॉर्ट आउट डिस्ट्रिक्ट बी डॉट बिगिन कॉमा डिस्ट्रिक्ट बी डॉट ओके सो इससे हमें हमेशा अपना सारा मिलते जाएगा ठीक है के सॉर्ट इज k-1 k-2 सो ठीक है जीरो तक बेसिकली क्योंकि लेट्स सबसे पहले बड़ा वाला आया फिर हमने जब इसको डिस्ट्रक्ट के को देखा तो आफ्टर सॉर्टिंग में भी हो सके वो फर्स्ट पे चला गया हो तो विल ऑलवेज क्योंकि हम हमेशा के -1 तक विंडो को चेक कर रहे हैं ठीक है तो ये दैट विल टेक केयर ऑफ ऑल द के सो लेट्स ट्राई टू टेस्ट इट वंस कंट्रोल सी कंट्रोल वी एंड ओके so that doesn't seem like a correct answer is it? Because with yeah एक सेकंड ओके सो हमने गलती कहाँ किया है लेट्स सी we took the so I think in input part there is no mistake. Yeah. Then think yeah, we should not K, we should print I printing K. We want 0 to K, right? Not the largest for an okay. So here we are getting 1E18. Okay. So at least now we know that here we are correct. Let's try to go in the Djikstra implementation and see here. So we made the priority queue pair of LL. Okay. Then vector pair, that is also correct. It comes as LL and greater pair. Okay. I think that is correct according to me. I have checked already. So we push 0 comma 1, then we our pp dot empty, we have this u, then we have this t, that is our node and it is our distance. pq dot pop, we did this pruning thing that if dist of uk minus 1 is less than d, then we continue, and then fill auto edges in the adjacency list of u. We have b equals to as dot first and cost as second, and dist of v and k minus 1 if it is greater than cost plus d, basically. So, okay, then pq dot. Uh, we are not maintaining a dist array, right? We should write dist of v तो करना होगा dist of v और k minus 1 हमारा cost plus d भी तो फिर हो जाएगा. ये तो कर नहीं रहा हूँ. Yeah, no, it's correct. So, let's try to okay, submit it. Um, try to check it. Okay. Yeah, it was a variation of Dijkstra where we have to take track of the kth largest distance. So nothing else, I guess. So if you are already familiar with Djikstra, this is not tough. This idea that we always relax in this manner, uh, the k minus one, and again sorting it. So yeah, this is fairly a good idea. That that might be tough to come up with. Okay, so yeah, so this is all for this video, I guess. So uh, yeah, we'll meet another one. Till then, keep learning and yeah, comment if you guys have any suggestions or anything. So, bye.